ವಿಷಯಕ್ಕೆ ಇದು ಅಲ್ಲಿ ಎಕ್ಸ್ಪೋರ್ಟ್ ಮಾಡಬೇಕು ಅಂತ.
This one, sir.
Yeah, yeah. பேசிக்கா போர்ட் லெவல் தெர்மலுக்கு இதுதான் யூஸ் பண்ணும். ஹைப்பர்லிங்க்ஸ் தெர்மல் அப்படின்னு போயிட்டு இது என்ன ஆம்பியன்ட் அப்படின்னு கொடுக்கணும். ஓகே, ஏதாவது பக்கத்தில் ஏதாவது போர்டு இருந்தால் அந்த டிஸ்டன்ஸ்லாம் தரணும் இங்கே.
Okay, sir. Okay.
Then go to the second page. Yeah, basically, board level thermal is for active components. These are the active components in the design.
Okay, sir. Okay.
Okay, based on the data sheet, this is the part number of the individual component, which is placed in column E. Column F, G, H are captured from the manufacturer data sheets.
Okay, sir.
Okay, and the wattage is given by the hardware designer, because many times we will not be going for maximum wattage for his design requirement or her design requirement. What is the wattage he will be giving? The customer or the customer has to give, or the hardware architect has to give. The
Okay, sir.
column D will be given by customer or the architect. He has to feed it, because many times no on the day I told no with TA and all no what is the wattage it will be giving. If you say mine will be a 3.3 voltage device and it can carry up to 2 amps, what is the wattage he will be calculating and then feeding this here.
Okay, sir. Okay.
Okay, this is the hardware designer's input. Rest of the things no all has
Data
to
sheet.
be fed by the system level or board level thermal engineer
Okay.
by looking at the data sheets for the design. Got it?
Yes, sir.
Yeah. இந்த போர்டில் வெறும் 4 ஆக்டிவ் தான் இருக்கு. பட் தெர் ஆர் போர்ட்ஸ் விச் வில் பி ஹேவிங் 20 ஆக்டிவ்ஸ் 25 ஆக்டிவ்ஸ் அந்த மாதிரி
Okay.
ஒன்றுத்தியா ஃபீட் பண்ணி we have to feed it in the tool. How to feed it and all, either tomorrow or tomorrow means either Monday or Tuesday, during your free time there will be one separate session on this. Actually board level thermal
Okay, sir.
tool எப்படி ஃபீட் பண்ணுறது அப்படின்னு உங்கள் போர்டே தான் யூஸ் பண்ண போகிறோம். How
Okay, sir.
he did it for SIPI, the thermal also will be done.
Okay, sir.
Okay, either tomorrow or if possible I will check if he is possible free today, he will do it right now. If not, but this is the plan. Based on this one no, the simulation will be performed and results will be like this. One second, I'll share my screen. But basic you see any simulation no proper inputs will give us proper results.
Okay, sir.
Okay, so that is important. So for your students, you should ask them for all the active components. Diode is active, transformer is active. What is the power dissipation? That has to be will be given by hardware architect. Rest of the things has to be downloaded from the manufacturer website.
Okay, sir. Okay.
That is the uh, input.
Okay, sir.
There may be some cases where theta JA will not be there or JC will not be there. There are some formulas, and based on the formula calculations, which is available universally in the web also,
Okay, sir.
based on those formula calculations, the power, the theta JC values have to be filled.
Okay, sir.
Hmm? Yeah, one second. One second, I'll share the screen. Once you can see the screen, you let me know.
Yes, sir. It is visible.
Yeah, these are the various chipsets which were in one of the design. Okay. all power dissipation will be provided by customer, or we have to feed it. Most probably, unless the customer gives, because he is the hardware architect, we will not be knowing. Rest of the things no has to be filled by us, particularly the theta j and jc values, which will be given taken from datasheet. Okay, and based on this, these results will be coming out, and how the compound profile at 125 degree it will be showing. See, based on some basic conditions, no, which tomorrow he will be explaining tomorrow in the next class, next discussion point. What is the open
Okay.
rack? What is the adjacent board spacing? What is the adjacent power dissipation of that board? If there are any, which direction the wind flow will be, airflow will be. This he will be feeding, and he'll be feeding these individual component values, and then get this results at 125 degree ambient, because the customer wanted 125 degree ambient, so the simulation has been performed with 125 degree ambient. So this is the top side component, how the component are placed in the PCB. It has been exported and the simulation was performed, and the results are showing here. This is the component temperature on the bottom side. This is the bottom side component. Okay. Yeah, this is the board profile actually. This is only the component temperature. This is the board temperature, including the PCB, how the behavior of this. This will be a very important data for the um, hardware designer or the system designer, so that where the heat flow is more, no, say let's say in this direction, in this, the temperature is around 170 degrees. So either he has to have some cooling mechanism here or here, or some vent holes in the center of the PCB, so that the air doesn't get accumulated here, or the heat doesn't get accumulated here.
Okay, sir.
Okay, or else the heat sink or the one of the fan, either this side fan or this side fan, it has to be used. But that is the system level. In the sense, a system architect will be looking at that. The role of system architect is to ensure that the product is working at certain ambient continuously. Okay, this is the compound temperature behavior. This is the board temperature behavior. More or less, it will be same actually. Both, if you look top and bottom, no, because it is a through hole, and it will be done at the same speed, no, either this one. So more or less, the board and temperature will be, unless more or less the flow will be same.
Okay, sir. Okay, sir.
Okay, these are the things which the simulation will be performed. Board level thermal will be. There is something called as gradient actually. How the behavior on the edges is what the gradient is all about. It will not be very significant, but as a report we will give it. But as a analysis engineer, your focus point should be on the compound temperature and the board temperatures. You see how we calculate this fail or pass, no? This is the maximum junction temperature which will be provided in the data sheet. If you look at the data sheet,
எங்கே
no?
போகணும் சென்டர்? ஓகே.
See, TG, okay? Storage and junction temperature minus 60 to 200 degrees. So we have calculated, put this as 200. Theta JA, somebody they would have given here, see, junction to ambient. This is the data sheet which is downloaded, and 400 is the value they have given. So we have embedded 400 here. This is the power dissipation given by the customer. JC is not available. If J is one of them, should be available, always there. We'll be ignoring this, and we'll be embedding the wattage given by the customer. And this XY location is the how the component is actually. We will explain in a better way in the original board actually. This is nothing but the XY location placement of the component. And these are the simulation results. When it is, let's say D01, probably, I don't know which is the numerical here. It is 149, no, 200, 140, it's pass. So 149, 147. Probably it might be this node because it is this 147, 149. No, it is this kind of diodes will be there because this is in this range 147, 149. Similarly, if you look at this one, no, this is one more part. This is one more part actually.
Sir, actually the measured temperature value is should be less than the data sheet value, right? Otherwise it is getting failed.
Yeah, yeah. Because as per the data sheet, they were told it can withstand up to 200 degrees.
Right, sir. Right,
What we are getting is 147. So we are considering this as for pass.
okay, okay, sir.
If you go down, no. So as per this data sheet or the it is maximum 150. Okay, but we are getting in this board it is 147. So we are considering this as pass. But here, no, for the second, no, we are getting 156. So 6 degrees more. So we are making this as fail. So we will
Okay,
go to that location. Probably it will be here. It is 160 and all, no, it will be in this in this region. Either we'll see the board temperature. It is here actually. So somewhere here, one small hole or a heat sink for this or some of the guidelines which will be incorporating to overcome this failure. Finally, all should pass.
okay, sir.
Hmm? This is what, as a board level thermal engineer, using software tools like Cadence, HyperLynx, Siemens, and ADS and all, they'll be doing it. This is the board level. Okay, and again, there is a system level which is different ball game. Since this is the PCB level, we have to teach this. We have to inform this to students.
Okay, sir. For reducing the
Okay.
temperature and all, we need to make what are the suggestions, sir, here for
Uh,
improving heat sinking?
Exactly. One is it's you see, as per this board requirement, the customer has told it will be inside a 125-degree chamber.
Okay, okay, okay.
Okay, hot chamber.
Okay,
But many times in our case, no, the board temperature it will be normal working condition.
okay,
It will be placed on some of the existing room temperature, which will be 30 degree or 35 degree.
okay, okay.
Okay, so we have to operate at 35 degrees. So here, no, we should uh, we should feed the value as 35 degree. Somewhere here they will be doing it. That also has to be considered ambient temperature 125 degree. Here in the tool, tomorrow when he explains, no, he will be embedding that 125 degree or board condition. The board will be operated with in a room temperature or in a temperature of surrounding the temperature will be called as 120 degree. In this case it will be mostly 45 or 40 like that,
Okay, okay, sir. Okay.
because this particular board no was placed near oven actually.
Yes, sir.
uh, that is the reason they have increased actually, but there are some boards. VTPL don't want 1 second. It doesn't have post thermal report.
ஹலோ சரி சரி இல்லை ஆமாம் ஏன் என்னாச்சு சரி 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 இல்லை இப்போ இது மீட்டிங் போயிட்டுருக்குது ஒர்க் லேட் ஆகும் தான் கண்டிப்பாக இல்லை இல்லை அவ்வளோ ஆகாது சொல்கிறேனே எப்படின்ட்டு. ஆ
This one more board. This is a system level. It will be tough for you to observe. We'll leave it. See, these are some of the components. Again, you can see a lot of boards components are there. It's not the final, it's a work in progress. So we would have told them, here it is example, it's failing, you please place this temperature. See, this is operated at 85 degrees. See, most of the heat opponent is in this region. So ideally, this will help in identifying for the system architect where to place the temperature. If you see here, it will be observed here. Here will be the more problem points. So a component will be attached to the heat sink. You know what's in the heat sink, no?
yes sir, yes sir.
Hmm?
Heating
Okay, I'm
wires,
fine.
for reducing the heat, right?
Yeah. This is the aluminum heat sink.
Okay sir.
Above the component, they'll be placing it or touching the component. They'll be see here.
Okay, okay sir, okay, okay.
See, this is the component. The heat sink is there. These are all processors actually. See here, this is the component. They have placed the heat sink. This is called as fins, and this is the X and Y dimension of the heat sink. See here, this is the component. This is the PCB, and the heat sink is placed this bottom side. These are the heat sinks. This copper heat sink. This is aluminum heat sink. See, this designing and all no will be very important at the system level. They'll be doing whether if you see this is three fins each heat sink, and the number of on XX also it is more. Whereas here no only two fins. In this itself we can see for this they have fixed one common heat sink fin, or here if you see they have split it into three. So the reason is this will be having more wattage than this. See, this, even if you open your CPU, no, you can see this kind of heatsink. Above heatsink, they'll be placing a fan.
Okay sir, okay.
Some of the laptops, no, the cooling mechanism is there. That is different. The fan also will be there. Heatsink also will be in addition to that. Like the wire is going here, no. This is the CPU of the desktop. A laptop will have some cooling plates. I will show if it is there. This is the laptop. Actually, inside the heatsink, no, the fan will be coming and some airflow will be there in this. See here, this. If you open your laptop, you can see this. The processor, the fan is there, and through one small aluminum, this one, the airflow will be happening, so that the fresh air will be coming inside. It will help in cooling. This is called as heat pipe design. They say. Yeah, see, this is kind of heat pipe. You can see here. This is again a heat pipe. You can see how the coil is. Yeah, this again is a heat pipe.
Sir, heat sink is always placing over the component or back side of the board, sir.
Yeah, that also is possible if it's a through hole, no?
Yes, sir.
There are cases where it can place on the bottom side also.
Okay.
See, in one of the things we saw, no, but predominantly it will be above the component will be there.
Okay,
Because
okay.
what happens, no, if this is heat, if it is ceramic, no, it's a non-conductive heat. The
Okay.
PC, this chip top.
Okay.
Okay, then there is no purpose will be there. So what they will be doing, no, at the center of this PCB there will be holes. At center of this chip there will be holes.
Okay, okay.
Through that it will be getting connected on the bottom side.
Okay, sir.
But when you have a heat sink and some metal, no, here, no, then it will be placed in the top only. We have done quite a lot actually. So this is one of it's pictorial only. I will see if there are some heat sinks which are placed on the bottom.
Sir, hello. Sir, session முடிச்சிட்டு மட்டும் நீங்கள் வாங்க கீழே கீழே ஹெச்ஓடி மேம் கேபின்.
See, heat sink is placed in the bottom. You can see
மாதவ்
it.
சார் மாதவ் சார் அவரும்
This is the
இருக்காங்க.
PCB.
நம்ம
This is the top side, and you can see the component. It's placed on the bottom
ஆமாம் ஆமாம் ஆமாம்
heatsink.
ராகவன் சார். ஹலோ.
Got it, no? But 99% it will be always placed on the top only. Etc. Nowadays, no heat management or heat avoidance is a
சார்
challenge actually.
சார் ஒரு
If you go
நிமிஷம்
to
முடிச்சுட்டு
Google videos,
முடிச்சுட்டு
no,
மட்டும்
I know
பேசுகிறேன்
how to
நீங்கள்
avoid heat.
மேலே
You
கேபின்
you
வந்துடுங்க.
you, you may see some of the memes showing they do omelette or this one in the CPU because of the overheat it's happening. They will make a coffee
அதுக்காக
or something like that. Heat sink memes you put.
சார் ஆ அப்படி
You
எதுவும்
can
இல்லை
see,
சார்.
I mean, not seen actually, but there are a lot of things actually. So, I mean, just to convey that heat management, the heat
சார் இல்லை
dissipation is a major challenge because the voltages are coming down and the currents are increasing
இது வந்து
for
யூஸ்
each
பண்ணணும்
chipsets.
ஹெச்ஓடி மேம் கேபினுக்கு. அதுக்காக தான் அர்ஜென்ட் சார் ரெண்டு பேர்த்தையுமே வர சொல்லிடுங்க. ஜாவாவில் இருக்கிற ட்ரெயினர் ரெண்டு பேருமே அங்கே ஹெச்ஓடி மேம் கேபினுக்கு மீட்டிங். ஓகே.
So, this is what I wanted to convey, kind of theory kind of thing.
புரியல.
Tomorrow or Monday,
சார்
he will do it.
மீட்டிங் போயிட்டுருக்கு சைமன்ஸ்க்கு.
Shiva.
வந்துடுறேன்
Okay.
ஒரு நிமிஷம்.
Monday post lunch, maybe 12
ஒரு
to 12:30
சார்
or during your
நீங்கள்
free
இந்த
time,
செஷன் முடிச்சுட்டு
we
வாங்க
can do
மீட்டிங்
this
வந்துடுங்க சார்.
illustration in the tool
ஓகே
so
ஓகே
that you can also show it to
சார்.
students.
ஓகே
Okay,
சார் ஓகே சார் ஓகே ஓகே.
fine. Any further questions on this?
Sir,
I'll be very
actually,
happy
I
to
have
answer,
one
but
more.
it's more theory.
Yes, sir.
Hmm.
I have one more doubt.
Go on.
Suppose if the particular component is getting more heat, no, we can
Hmm.
remove and we can use the same configurate with some other IC. இப்போ ஒரு
Yes,
manufacturer
yes, yes.
யூஸ் பண்ணுற
Yeah,
காம்பனன்ட் கூட யூஸ் பண்ணிக்கலாம்ல சார்?
yes. But it should meet the design requirement.
Yes,
Okay.
yes, yes. Number of
If the
pins,
design
number of
requirement,
pins and
exactly,
shape size and everything.
correct.
Yeah. Okay.
Yeah. Basic this simulation will be providing you the guidance to the enclosure design. Okay.
Okay, sir. Okay.
If assume that this board is there, this is the board. you cannot have only the board as a product, no, it will be having enclosure. Once when we do this thermal simulation and then see this is the how the heat flow will be or the thermal flow will be, we have to the designer, the enclosure designer will have, this what do you call this cutouts or this small this one here, so that the heat gets dissipated like this, or one fan will be here,
Right, sir. Right, sir.
exhaust fan, so that the heat all will get absorbed through the um, through those small what do you call mechanical people will be knowing it. See, these kind of things, no, the purposely they do this to avoid to take the heat out. You understood my point?
Yes, sir. Yes, sir. Yes, sir. Sometimes a laptop itself, we are seeing the same thing, right? Some small,
Yeah,
small
yeah, yeah, yeah.
pores.
Exactly,
Okay,
exactly.
sir.
But you see, unless that's what it is in which working condition. Yeah, as you rightly told, that's one of the option. But there are some cases where even unnecessarily to take the heat, no, it should not end up all some dust and all comes and then comes inside. That also we have to see. Okay, there are
Okay, okay, sir.
some. So there are some thermally enclosures, thermally conductive enclosures will be there, which they'll be using that. You see, like this actually. See, because there are we cannot have fins, holes. No, these are there is a mechanical term for this actually. I forgot the name, but that's a mechanical term for this. But for all we cannot have that actually. If you have no unnecessary dust and other things will come out, so there will be a closed enclosure will be there, and the heat this itself will be acting as heat sink or something like that. Some design they will be doing it. When you
Okay,
have
sir.
IP64 compliant products and all, no, we cannot have just holes like that.
Okay, sir.
No, no, that's what I mean. I don't want to confuse and then make you scary. These will be very important input for the system designer or system architect who will be looking at the enclosure, bigger enclosures and all, any product.
Okay, sir.
Okay. Any further questions? I'll be very happy to answer.
Okay, sir. That's all, sir.
Okay. The same will be taught with your same board by tomorrow, Monday, by Shiva.
Okay, sir. Okay, sir.
Hmm?
Okay, sir.
Okay, then fine. Shall we drop? No, or any questions? Others have any questions, means they can ask.
Sir, I have only one doubt regarding
Yeah.
this our for manual preparation.
Hmm. Manual preparation.
Yes,
Okay.
sir. Yes, sir. Yes, sir. For this one, sir, power integrity and thermal analysis, we need to include, sir, here. That
Hmm.
input and output result we need to include here, sir. Analysis of power integrity and thermal analysis. That is 10th experiment. Actually, we need
Okay.
input and output file, how it's look like as per our new design, sir, actually.
Yeah. I don't know whether Somshekhar has shared the PA input form
Okay,
that
okay,
you can embed it, and thermal he has shared. No, you can use that the Excel file.
okay. And this were analysis of signal integrity and reflection, crosstalk, and report making.
Hmm.
And here we have received some documents, sir. Whether that is okay
Hmm.
or we can include it one.
No, no, that document is what will be there actually when you or anyone will be making. No,
Actually,
it's a industry one standard only.
okay, okay, sir, okay. Okay, sir.
Finally, I mean, basically,
Okay, sir.
uh, some customers or some industry or companies will be having on the left hand side, some will be on the right hand side like that, or the color will be varying.
Okay, okay, sir, okay.
Okay. But the main content will remain the same.
Okay, sir.
The waveform will be shown, the
Okay.
frequency will be shown, and what are the results capturing, rising, falling, and all, it will be known.
Okay, okay. ஃபார் எனி ஒன் எக்ஸாம்பிள் பின் இப்போ பார்த்தீங்கன்னா ஒரு பர்டிகுலர் பின்னுக்கான சிக்னல் இன்டெகிரிட்டிக்கான ரிஃப்ளெக்ஷன், கிராஸ் டாக், ஸோ இதுக்கான ஏதாவது ஒரு ஒன் ஆர் டூ பின்ஸ், இப்போது ஒரு குரூப் ஆஃப் பின்ஸ் நம்ம டெஸ்ட் பண்ண போகிறோம் அப்படின்னா அதில் ஏதாவது ஒரு பர்டிகுலர் பின்னுக்கான ரிஃப்ளெக்ஷன் இல்லை ஏதாவது கிராஸ்
Yeah,
டாக்ஸ் இருந்துச்சுன்னா அதை மட்டும் ஸ்பெசிஃபை பண்ணி நம்ம இன்க்ளூட் பண்ணிக்கலாம் சார். அதுக்காக பார்த்தோம்.
yeah. I thought this Somshikar shared that only. I thought.
Yes sir, he shared that one, but we don't know exactly which one is matched with that one, so that's
Okay,
why.
okay.
Okay sir.
We can. Can you open that what he shared?
Yes sir, definitely. This one sir, actually.
Yeah. No, this stack up. Okay. If you want to embed the stack, basically what we have to tell is because this is what they'll be manufacturing. No, we will be telling them that the stack up used is what when they do the testing they can correlate. That's it.
Okay sir.
Come down.
Summary interface name
Yeah, yeah.
and signal clocks.
This is okay. No, no. Signal name. Yeah, it's a name actually. You
Okay.
can. Or I'll tell you. Okay. There'll
U11
be
and
many.
U17, it's act as a driver model, and this one receiver as
Yes, yes,
driver and
yes.
receiver.
See here.
This
Okay.
one,
So
this one
what
is
it
called.
is
Yes, sir. Actually, this is comes under crosstalk or reflection.
this reflection.
This is reflection. Okay, sir. Okay.
Okay, why we call this as reflection analysis is
Okay,
we are
sir.
seeing at the receiver. Okay,
Okay,
when you
sir.
are seeing at the receiver, no,
Okay, sir.
how the behavior is.
Okay, sir. Okay, okay. Okay, sir. Okay. And crosstalk, for crosstalk.
Yeah, come down. Okay, crosstalk.
One
Was there
second.
any other Excel?
Yes, sir.
One more, one more X.
Word document is there. Once again. Board analysis and results. This one.
Yeah, this again same actually. Instead of B versus T, no, this is again I diagram only.
Okay, sir. This is comes under reflection or crosstalk. This one, sir.
This again we can say reflection.
Reflection
Yeah,
loss.
this is insertion loss.
Okay, sir. Okay.
Yeah, this crosstalk you can see it. Double click on this Excel. Yeah, open.
Yes, sir. It is open only. Yes.
Yeah,
Crosstalk 10
no,
percentage of the input
no,
voltage
go
swing.
exactly. Go to second page.
Here it is showing only one page only, sir. Yeah, this one SIP.
See, what it is showing is this is the net names.
Okay, sir.
This net is coupled with these two nets,
Okay, sir.
these nets, and the driver is U12
Okay,
and the receiver is U14,
okay, sir. Okay,
and we are getting a coupling value of 15.49 millivolt.
okay, sir. Okay, okay.
If it is 200 or 300, then we would have told you to adjust and move the space further so that the rise of crosstalk values are minimal.
Okay, 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 sir. Okay,
And this is the model used. And this is the inside the IBS. There will be many submodels.
okay, sir. Okay,
And this is the driver name of the model. This is the receiver model used. Receiver name of the model and the conclusion pass fail.
result password. Okay, sir. Okay, okay. Okay, sir.
Okay, you have the board, no? What I suggest when you during your free time or your this one, no,
Okay. Yes, sir.
you can reduce this one to between the space of this net name N2084737 and FPGA ADAR one SDI 0
Okay, sir.
and F underscore TS.
Okay.
These nets, no, you
Mm-hmm.
bring it much closer.
Okay, 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 sir. Okay,
You can see the behavior of the reflection crosstalk going instead of 15, it
okay,
will be shooting to 300 or 200 like that.
okay, sir. Okay,
Also, for the sake of discussion, since it's a tool, no, it's a training, no, go to the first page. Yeah, this is a 3.3 volt device. No, instead of 10%, make it 2%. So the 2% of the 3.3 volt will be maybe 66 millivolt.
Okay, sir. Okay.
If that is the acceptance limit, then go to the second page. Let's say 2% of the voltage level means item number 2 will be marginally only passing, only 26 millivolt will be there.
Okay, sir.
So as a designer, you have to move little bit further. This
Mm-hmm.
FPGA ADAR CSB1
Okay, sir.
and N208437 and ADAR SDO1 needs to be spread out little bit more,
Okay, sir.
so that the crosstalk is coming down, instead of 40 it will be coming down to 15 or 8 or 12 like that.
Okay, sir. Okay.
Okay, when there is NA means there is no crosstalk,
Okay.
means the already the spacing is more.
More. Okay. Okay, sir. Okay. So we need to reduce this one, right, sir? For better,
No, no,
it
no.
is. For better one is there is
Yes,
no crosstalk here. As much as minimum, we need to reduce it. Yes, sir.
exactly. No, no, no. What I meant is, when they route it, no, let them route little bit near,
Okay, sir.
all near, so that this will be going to 60 volt. Then it will be showing as failed,
Okay, sir. Okay.
because 2% drop will be more.
Okay. Okay. Okay, sir.
Okay? Because they have routed little bit away, so we are getting all our pass now.
Pass. Okay, sir. Okay. Mm-hmm. Okay, sir.
Hmm? He taught you know how to assign the model and then how to run the crosstalk.
Yes, ma'am. Yes, ma'am. Yes, sir.
Okay, then fine. If not, one more walkthrough he will be doing it.
Okay, sir. Okay.
Okay. Any further questions?
Yeah, sir. That's it, sir. That's it.
Okay then. Hmm. Thanks all.
Thank you, sir. Thank you so much.
Bye.
Bye, sir.